It's an aerosol innovation at Washington University in St. Louis, and this team of researchers say they can do what others have not: a rapidly administered handheld breathalyzer test for COVID-19. It's a device researchers say delivers fast and accurate results inexpensively.
If you ask a sick patient to volunteer and just blow into a device, they would tire themselves out breathing for 15 minutes into a commercially available device. What we did was we came up with a user-friendly, disposable, handheld box, 3D printed, where a patient would need to just breathe once or twice, and that is sufficient for detection.
The breathalyzer is now being developed for more than COVID-19. It would also help identify influenza A and RSV, in addition to COVID-19, in one breath. One breath test in under a minute.
To get a reading whether you are positive or negative. So this technology is essentially a phase change which takes place from air to a liquid medium, but keeping the particles in air at the same time in the liquid intact for detection.
The engineering of the breathalyzer is happening inside Rajan Chakrabarty's laboratory. He's an associate professor in the Department of Energy, Environmental, and Chemical Engineering at the McKelvey School of Engineering. This experiment mimics the exhalation of aerosols from humans. It's called a chest device, mimicking coughing, hacking, sneezing, and talking.
And we will show that how the breath box collects it.
For participants in the breathalyzer's clinical trial, Chakrabarty says doing the test is as simple as the researchers insert a straw into the device. A person blows into the straw. The aerosols from the person's warm breath collects on a cold surface inside the device, which are then read by the biosensor. Chakrabarty says the engineering of this box and straw aerosol technology is inspired from an experience observing a child with a juice box.
We were struggling with it for almost a year. When I was traveling on a flight from Japan to New York, next to me there was a kid who was playing with a straw, trying to blow his own breath into that box, which was empty. And he was trying out all sorts of fancy things. He was blowing into the straw, closing the end from the other end. He wanted to really deposit a droplet. And then finally, he discovers is that if he freezes the straw by dipping into like cold water and he blows hot air from his mouth and he sees one drop like forming. This is after struggling with it for 2 or 3 hours. And then it struck me, we could do a similar thing with the device. And it worked. Just slides down and deposits on the biosensor.
The other key technology is the biosensor. That's where Dr. John Cerrito, professor of neurology at Washington University School of Medicine, and Dr. Carla Udy, an associate professor of psychiatry, step in.
The biosensor work and the protein work is usually done in my laboratory in the Department of Neurology.
The breathalyzer uses a biosensor adapted from an Alzheimer's disease-related technology Cerrito and Udy developed a decade ago.
And we had the idea, can we convert this for something for COVID instead?
Transferring what we knew about creating electrochemical biosensors for Alzheimer's disease to make it specific to COVID.
And now, 2024 is a big year for the research team. They recently received a $3.6 million grant from the Flu Lab, an organization that funds efforts to defeat influenza. The money is used to adapt the initial COVID-19 breathalyzer to screen for influenza A and RSV in one breath.
We're also trying to expand this to detect other targets. So any other antibody that we can develop and attach to these chip-based electrodes could then be used to screen for the flu or RSV or fungal targets or
other pathogens, including emerging pathogens or bioterror threats in future designs.
We can measure proteins very quickly and very sensitively.
The grant money is helping the team with clinical trials.
The results are looking really positive.
We're at the point where we need to convert that into a commercial product.